So, the first words will be, I really appreciate being given the opportunity today, because sometimes, Southern, we tend to sometimes self-inflict isolation on ourselves, and sometimes we're not included. And actually being given an opportunity to talk about all the exciting developments, what we're trying to do in the Southern, is a fantastic opportunity, and I welcome that opportunity today. Because, just to put this all in context, at the moment, on the Southern, we have about 84% of our network is already electrified. That doesn't mean that we're sitting and not thinking about the other 16%. We are clearly thinking about that. And of course, in the Southern, we also have the exciting only overseas division within Network Rail. It's a little blob down the bottom there called the Isle of Wight, which is, of course, electrified. So the talk today is partly about our vision, about where we want to go to as Southern Region. And I've got a slide that sort of goes around the points of what that vision is, and then I've got a few more slides just to expand on some of those points. But just to begin with, all of what we do in Southern, we've got three key principles about how we do all of our work that applies to everything we do. So it's show you care. A nice one that I like really much is keep it simple, and listen, learn and improve. And all those things runs through all the type of work we do, be it maintenance, be it enhancements, be it strategy, be it our people. They are the key principles that we work to. So let's start on the vision. Now, because this is a vision, there are no dates for some of these. They are aspirations of where we need to get to, or where we want to go to. But it's really important, I think, to actually have that view about where you're going, and then you can plan that journey about how you start. Because if you never start, you never get there. So the first one is about electrical accidents. And, you know, we all, in any electrified network, the very nature of a contact system is that it's got an exposed conductor. It doesn't matter if it's up in the air or down on the floor. So we have to clearly have a process of taking isolations when we're working on those systems. I've got some more slides later about our NSEDs, but basically we are trying to take away people from the infrastructure in terms of setting up isolation. So we're walking away from isolators that have to be operated locally to control devices operated by the control room. We are moving away from fitting short circuit straps on the infrastructure to fix pieces of equipment. We're also improving electrical safety in depots by clearly looking at walking routes, making sure that we do the best we can to keep the conductor rail clear of walking routes, double height guard boarding to try and minimise and mitigate the risks of that in the depots, but also the smarter part of the isolations. And this is a key part, and it is quite difficult, is fitting a possession or access around an isolation and not the other way around. Because by doing that, we can optimise the isolation. We can actually make maximum use of all the devices that we're actually fitting to the infrastructure. We want to try and minimise the number of service-affecting faults on our network. So in our work on modernising the way we do maintenance, it's taking the standards at a start, but then looking in a key way at what we do, how we maintain that equipment. It's using condition monitoring techniques. It's using all sorts of test techniques. Sometimes that means we can then talk about pushing some maintenance out. Sometimes it means doing things more frequently. But there's still gain in doing certain things more frequently, because then we can push other interventions further back. It's all about trying to do the right intervention at the right time. And one of the things in Southern we are clearly trying to do here is grasp, not just take what the standard says and follow it. We want to lead that conversation. We want to be able to challenge. We want to be able to go back to the tech authority with a compelling argument about what we're doing is right. And that runs through all of what we're trying to do in Southern. We want to try and lead that conversation. We want to use train bore monitoring more on the conductor rail. We want to look at ways that we can monitor the condition of equipment to potentially refurbish to push some other renewals further out. Even though some of the equipment is already 50, 60 years old, we still, where there is a case for doing so, we want to actually challenge in general industry to actually get those techniques where we can safely and with the performance we want push some of those interventions further back. We want to be the industry leader, if you like, on third rail DC systems. That doesn't mean that we want to ignore, for example, Dean and Simon Thick, who have got parts of DC systems and third rail systems in their regions. This is about saying, let's grab that conversation, let's work out where we want to go strategically, and let's lead it. Let's not wait for the tech authority or anyone else to tell us what we can do or how we can do it. Let's work together to actually get where we need to get to. And that clearly involves everyone. It isn't just Southern Region. That involves all of our consultants, our contractors, our suppliers in that conversation about what the art of the possible is. It's about developing new technology. It's about sometimes initiating those conversations about developing new bits of equipment that otherwise might not be developed. It's about having all of that, because it's really important. Rather than people saying, we're not going to develop this, if you don't understand why you want it. It's about explaining, it's about saying how that fits into the vision, why that's so important for us, and actually how we can then also help invest and get those products that we actually need. So we talked a lot about decarbonisation today, and I've got some slides on this. We're very much looking at power generation, be that solar or whatever. Energy storage, we've got a number of both DC and potentially AC energy storage schemes to help us with the challenge on decarbonisation of the actual electricity supply. We're very much integrated with our TOCs, our train operating companies, in trying to work out what the best route for decarbonisation for diesel trains are. Is it electrification? Is it battery? Is it a hybrid? And I've got a few more slides later for that as well. So fit for the future, Dean's just talked a lot about modelling system capability, capacity, and one of the key things we want to do is we want to try and lead that conversation with the department, with the train operators, with system operator. Because even on the DC network, especially if we need a new grid supply point, it can take 5 to 8 years to get a new grid supply point, if indeed it is possible. It can take 2 to 3 years for a medium-sized upgrade to be able to do it. So it's no good someone coming to me in 2 minutes' notice, oh, we just bought a new fleet of trains, we want to run it. It's about constantly trying to have that conversation, to be in there at the time those decisions are being talked about and made. And ideally, the vision is to have a strategic level of capability, capacity for every line of route. Because then timetable change is easy, isn't it? Someone wants to buy a new fleet, you make it like that number of trains per hour, no problem. I have to say we're not quite there yet. And unfortunately, one of our strategic projects suffered partly because of, not suffered from COVID, but suffered because of the industry shock as a result of COVID, which has put us back a few years effectively in that vision, but it's still there. It is about embracing new technology. It is about talking about when we've got the diesel routes, do we go 25 kV, do we do 21st century DC electrification? And I've got a couple of slides on that. And the other one is, again, we talked a little bit this morning about people. So I always talk about a conveyor belt of life. And we've got a number of people in Southern that are towards the right-hand side or the end of the conveyor belt. And we've not got enough people to compensate for those that are going to fall off the end of the conveyor belt. Me included. So we've tried to grasp that and say, if we keep doing what we're doing, we will end up with a major problem or a worse problem than we've got today. So what we want to do is, for example, we're trying to grab, it's probably the right word, all the initiatives of taking people on board, be it the apprentice scheme, the grad scheme. I want to reintroduce a technician trainee where we get good sort of, in old language, apologies for my old language, OND, HND, HNC type people into our organisation. And we absolutely need to do that, and we need to do it in a way where we then got some training. So I've been talking to the PWI about being involved in helping develop some DC engineering training courses, because they don't really exist at the moment very well. So bearing in mind we've got a lot of people we need to bring in fairly quickly, and then we need to have time while people are still on the conveyor belt to be able to download some of that knowledge actually into those people. And that hopefully then starts getting us a sustainable sort of progression plan for people, and actually you know, it's then not a shock when someone decides to either leave or they do fall off the end of the conveyor. So one of the things that I think for me in my career has been an absolute game changer has been the Safer, Smarter Isolation programme on Southern. So the picture you see on the screen at the moment is what people had to historically carry to site to fit to protect effectively the conductor rail from being re-energised, for either a train running into the section or an ECO making a mistake and recharging a section. A short circuit strap is like an earth. I always get very grumpy when people talk about earths on the DC system, because our whole DC system is specifically not earth. So they're not earthing straps, they're short circuit straps. But they carry out the same intent effectively. And unfortunately, we've had a number of incidents where people, if they follow the process correctly, they follow the safe system of work process to get to site, it's 100% safe. It takes time, but it's 100% safe. Unfortunately, sometimes people don't follow the process, which is where we're also doing a piece of work on behaviours about trying to look at, because replacing one process from one to another doesn't actually do anything if people don't follow the process in the first place at all. And it's about thinking about those behaviours. Why would someone want to kneel down in front of a potentially live conductor rail and offer up a short circuit to it when the only way it's going to go is badly? And having seen the results of someone and been involved in an investigation with someone, it does go badly. So the whole process and the whole principle of what we're trying to do is to take people away from going on the infrastructure. So we're fitting control track switches to replace hook switches or what we call TD devices, which are locally operated disconnectors. Because then it's the ECO that operates them, not anyone having to go out on the infrastructure. The short circuits are created with fixed bits of equipment at substations, so we don't have to go line side. That saves train versus person risk. It saves person versus electrical risk if they don't follow the process right. The local control panels we use at the moment are all located in a position of safety. They're right by an access gate. They're right by an access gate that's got a place where the van can be parked. So it makes it easy, and it makes it straightforward, and makes it safe for people to carry out that task. So fundamentally, it cuts down the number of people needed to actually go out on site and actually fit the short circuit straps, cuts down on slips, trips and falls risks, which is one of our biggest risks out on the railway. And it significantly reduces the risk of person versus electricity. The other thing it does, it also gives us some additional time, because it's much quicker operating a switch than it is to get agreement to go out and fit the short circuit straps or operate hook switches or both. That can take 20 to 30 minutes longer than operating the equipment that we've installed. So that means we've either got more time to do a little bit more work. On Southern, we have such wonderful access times, sometimes of actually only being able to do 2 hours work on an overnight access. Giving another 20 to 30 minutes in that 2 hours is significant. It sometimes means the track people can do 2 welds instead of 1. Then we don't need to put a speed, don't need to go back, don't need to put a speed on because it's got a high-speed clamp or whatever it is. The track engineers would know far better. I'm moving away from that. I'll get into difficult territory if I start talking about rail clamps. So there's lots of other added benefits from the program we've undertaken. But the key thing is it's not something for that. It's fundamentally a safety program that's actually got some benefits, some time benefits within those access windows. In Wessex, we're probably about, at the end of CP6, we will be about 75–80% through the program. That's just because there was a particular RAM at the time that was leading this program that decided we needed to go hell for leather and do this implementation. The other 2 routes wanted to see how it went, which I could always tell them would be well, but by the end of but by the end of CP7, the intention is, provided we get the funding to be able to achieve this, that all fixed equipment at substation TP huts will be fitted with NSCDs, and we will fit the most commonly used hook switches or trap disconnectors will be replaced by CTSs. That is tinged with that condition that clearly we don't quite know what we're getting in the CP7 settlement. We're making a very, very strong case for this on the basis of safety, on the basis of the other benefits that we get out of doing this work. And I think the other really important thing out of all of this is we've always adopted an incremental approach to this. Right? I think sometimes the railway can let itself down by waiting for utopia before it starts. Okay? If you do that, you never start. So we've started off with just the NSCD, which was one that's fitted to every electrical section at a substation or TP hut. Over a period of time, we've developed the tools in the toolbox. So we've now got the busbar short circuit device, which means we only need to fit 1 in a site rather than 4 or 8 or 12 or how many tracks there are. So in terms of equipment and installation, it's a lot quicker. It's less flexible, so we have to use those on the more remote areas where that lack of flexibility doesn't matter. But it gives us another tool in the toolbox, which means we can do more coverage for the same amount of money. And we talked today about making things, tackling the cost. That was one of the ways we're tackling the cost of fitting this equipment. We've now got an integrated control track switch with negative short circuit devices. So instead of fitting a CTS and then having to fit separate short circuit devices, we've now got one box of tricks that does everything. Which for installation is just so much quicker, easier in terms of installation. And the installation costs are probably about 80% of the cost of doing the job. So that's a real key element. And we've also got an integrated DC circuit breaker and NSCD. So when we're now coming up to renewals of some of the older DC equipment, we can put in one piece of kit that's got 2 functions. So that piece of kit is slightly more expensive, but it's 1 rather than 2. And again, the cost of installations are massively reduced. And it's a real game changer as well, where we're in short space, where there isn't just the room on the infrastructure to fit devices. We're also got consolidated control. So all the current devices are operated through a local control panel, but they just operate for one substation or TP hut. We now developed a consolidated control where we can control 5, 6, 7 sites from one location, which means that, again, we then don't need to put the local control panels, which could be a mile away from the substation. So it makes that cheaper, and it actually means we only need to send one person to go to site to operate the equipment. And we're not even stopping there, because the ultimate, and this is where we always wanted to get to, but if we hadn't have done all in the blue and the first line of the consolidated control panel, we wouldn't have started yet, is remote secure, which is where the negative short circuit devices, the CTSs, they're all controlled by the electrical control room operator, and we then use smart devices, smartphones, to be able to lock out those devices so that the ECO can't, or no one else can effectively access and control those. So that's the next one. That's the current challenge, if you like, of trying to make that affordable and trying to have pragmatic conversations about how we can get this affordable and sensible in terms of price. So in terms of decarbonisation, in terms of decarbonisation, I'll go straight to this diagram. This is the diagram of effectively our system, where we take supplies from the DNO or National Grid, and then we've got our own high voltage distribution system. So at the moment, our tariff is with Nuclear Electric, but could be with anyone. And what we're looking at here is making an efficiency in terms of reducing that unit rate and unit price. So we could go a PPA to go and build an offshore wind farm, say we're going to buy all the output, and then use the DNO system to distribute it to our network and use it that way. Or because we've got a 33 kV distribution network ourselves, we can actually embed it within that as well. So we've actually had, let's just put that to one side a minute. So Aldershot, we had the other thing we tend to do in Southern is we go for a proof of concept rather than talk about a big scheme that's going to cost millions or billions. So Aldershot was an example. We worked with Riding Sunbeams to create a very small solar PV system that fed the traction network. And the fact is, you do the same amount of engineering assessment on a small scheme than you do a big scheme, but it's much easier to get the funding for a small scheme to prove concept. And actually identify and highlight some of the difficulties with this. We then moved on to a much larger scheme where the engineering was a challenge, but that wasn't what ultimately caused the demise of the project. Of course, it was the commercial, the procurement way of how we could sign up to a power purchase agreement to actually buy this energy. And I think that's what we always have to keep in mind a little bit, especially as a public body now with public funding rules, which makes it much more difficult to be able to contract with a party that wants to be able to do it. So where we've moved to on that is we've now got a project which is looking at our network, saying where is the best locations that we could put a solar input that's big enough to make it worthwhile in terms of business case, but we will lead that conversation and then go out to tender who can actually provide that for us. That piece of work is currently going on, so it's not finished. It's not that we're not going anywhere. That's the next stage to actually move it, hopefully, to a deliverable piece. And of course, that could be solar, it could be wind, it could be tidal, it could be anything, ultimately. And then we talk about the replacement of diesel traction. So we've been working on a number of different ways that we could actually achieve that. One of which is DC electrification, one's 25 kV. Does battery work? Is it electrification battery hybrid, or is it hydrogen? Each line's got its own very specific set of circumstances, and not one size fits all. It's not a case of saying the answer's battery, what's the question? It's a case of working out, where is the sweet spot? So, for example, Uckfield line, that's currently a diesel route from Hurst Green to Uckfield. the outputs need to be a 12-car railway. A 12-car railway means hydrogen doesn't work with the amount of space you need to carry the hydrogen around with you. The battery doesn't work because you've got such an immense amount of energy to try and get in that 12-car train to run 40 miles there and 40 miles back again that it just doesn't feasibly currently work. So Uckfield, electrification is the right answer. 25 kV is one. If it was cheapest and had the best case, why wouldn't we do that? By the very nature of the words I'm saying, I think you probably can guess the DC electrification came out a lot cheaper in terms of where, that particular line. So we've been working with RSSB on 21st century electrification. We've been working with our colleagues in the ORR about what do we do? How we, looking at risk, looking at be it 25 kV, which I know there's all sorts of conversations about risk, about designs and clearances and stuff like that. For DC, we've been having conversations about what are those key areas of risk, doing a CSM, common safety method type safety justification argument about where are we, what can we justify in terms of changing a historical design but making it, if you like, a possible future compatible design. So, and that work's not finished yet before anyone says when are we starting building it. We are carrying out a trial of a platform switching scheme. So one of the key areas on third rail is in station areas, a bit like 25 kV, that you can have people that fall off platforms because they fall off platforms. You can have drunk people falling off platforms. You can have people just wandering between the tracks without using the bridge or the subway. Sometimes there is a level crossing by the station that people just decide to go for a walk down the railway. And sometimes it doesn't end very well. So one of the things we're looking for is how can we mitigate some of those risks without it costing such a vast amount of money that there wouldn't be any business case to do the electrification. And this is a very, very simple idea that we want to develop. So the network configuration is exactly the same. It's a traditional scheme, other than the station area is fed through a form of switched supply that is switched by the train when it enters that particular section. And how it's switched, what the equipment is, the one thing I will say is that I keep going back is it's got to be simple. So it's not integrated with signalling. It's a very, very simple scheme that means it's going to be affordable to install. Any new DC electrification scheme would have the safer, smarter isolation embedded in it in the first place without having to go back and retrofit it. It would be designed for that work philosophy, that strategy, so there's no residual hazards in the way it's designed. So that means that we are protecting and managing the risk to workforce. And then the platform switching scheme is a way of trying to protect passengers and publics and actually some trespassers in the station area. One other way of doing it, and this is the other thing that we're speaking to the train operators about, is putting a small traction battery on the train. Because actually, if there is a small traction battery on the train can rock up, station would be normally de-energised, goes into battery, pulls away on battery, and then goes back onto the conductor rail. And then for us as Network Rail, all we need is a switch that if the train gets stuck there for any period of time, we can close it and make sure the train doesn't lose its battery supply. So that's the sort of element where we're looking for future DC electrification. I have to say it depends on, as I say, Uckfield it worked that electrification is the right answer. North Downs, what we're trying to work on is where's the sweet spot between fitting a battery on the train that you charge, because it's a 3 or 4 car train. What does it mean to keep charging it? What level of supply does it need? Is it better fitting a smaller traction battery and electrifying a little bit? So one of the bigger gaps, we actually put a bit of fixed electrification in, but still accept there are bits that are fitted with no electrification. And we are working on those principles about where is that sweet spot. So battery might well be part of the solution, but it's certainly not the universal panacea for everything. And then really just finally for freight, we've obviously got the heavy freight corridor from Southampton. And at the moment, one of the things is what do we do with that? Is that DC? Because we can provide DC infrastructure. We did on the Channel Tunnel routes to provide two Class 92s an hour hauling freight. We can do it. We just need the time and the money to invest in the network to do it. Or is 25 kV the right option? But actually, there's another factor here we need to consider is no matter what type of electrification scheme we put in, we need to be able to maintain the railway. So at the moment, we have 2 diversionary routes that we can divert freights overnight or in the day if we need to do work on the railway. If we went on an electrification scheme that was only gave one shot and you're out, then as an industry, we need to accept that either we've got to electrify the diversionary route, as we do, which is probably the right answer, or accept that there are times where we will be disappointing our freight customers and our passenger customers because we're just going to say it's one fault on the main line and then it doesn't work anymore. So I think in reality that's really where I wanted to get to. I didn't talk actually about the number of trains we run on the network. When I had my first slide about Southern Region, I think it said about 1/3 of the passenger trains per day on the network are run on Southern. We have a tremendous load, and this is post-COVID. People think commuters have all gone away. They haven't. And actually, all that's happening is a little bit like Dean talked about, is that the lump in the middle that was the hollow for the middle of the day is just filling up with load. And there is maybe a little bit less in the peaks, but not a great deal. So it's really important for GB that we have a successful Southern Region. That means that we need to have the people, we need to have the processes, we need to have the tools, we need to have the development, we need to have help from our suppliers and contractors to help us to achieve what we want to do. It's a really exciting place to be. Sometimes, you know, a few years ago, there were talk about how long is DC going to exist? And actually, the answer for Southern at the moment is provided it meets the outputs, i.e. we can run the train service that we want to run, we've got no intention of changing it. We want to make it better, we want to make it safer, we want to improve the performance of it, we want to improve the capability of it, where there is a case to do so. And so I'll sum it up with the final statement that, to me, the future is exciting. There's lots of innovation in our space. We are leading some of that conversation, even for the whole of railway. Even if you look at solar, we had the first, albeit very small, solar power feeding traction in the world on a DC system. That's where we want to be, leading. We want to have that conversation, and we need great people to help us do that, and we need to have great suppliers help us with that as well. So, thank you very much.